one of the hardest things with computer science and computer programming in general is something that's really hard to teach in class or via a textbook, but that's not going to stop me from trying anyway. And that's the idea of debugging. Now, the process of debugging refers to fixing these bugs or errors that crop up in your computer code. Now, the word bug, let's see, it's we don't really know where it comes from, but anecdotally, it comes from this over here. When Grace Hopper was working on, let's see, one of the first computers out there, one that was a vacuum tube-based computer, some of her associates found this bug, this moth, in relay number 70 in panel F. A moth in relay. A literal bug in the computer that was causing it to go on the fritz. Anecdotally, that's maybe where we get the term debugging from, but notice that no one's really used the term debugging here. But that is an interesting story, I think. But when it comes from for debugging issues in computer science, you have to deal with multiple types of errors. There's errors that you get, which we'll see, which are syntax errors, where basically you wrote the code and in such a way that the computer's like, that doesn't make sense. You said words, but I don't understand any of them. There's runtime errors that you can get because you run the code and your computer and the program crashes on you. And then there's my personal favorite errors, the personal favorite things that my personal favorite bugs, where the program works, kinda, but it doesn't do what you expected it to do. And I think that this book has a great example of it, which is why I have this page pulled up. So here, this is a program that's basically going to build up, basically saying, ask the user for the time now in the hour 0 to 23, and ask for the number of hours to wait. Wait, your program should output what time will be on the clock when the alarm goes off. So let's go ahead and run it. What is the current time in hours? Well, let's go ahead and say, hey, it's like 9 o'clock in the morning, so let's go with 9:30 in the morning. Okay, and I want to wait, say 2 hours. So we should get 11:30, and so 9:30 and 2. Although it does say an hour, so I really should have put 9. And I'd like to wait 2 hours. Now notice that it's not really doing what we need it to do, right? That it's asked us for the time now. And it's asked us for the number of hours to wait. But it hasn't, done any calculations yet. And that's important that basically you stop and test this portion out. One of the most constant things I see people who have trouble programming do is that they try to write the whole program at once without testing any of it, or they run into an error and they don't try to fix it immediately, and they say, I'll fix it later and hopefully something I do later is going to fix it. Nothing you do later is going to really fix it. You gotta figure out what that issue is now, and deal with it then. Nothing of what you do now, what you do later is not going to fix the issue you have now, usually. If you've got an error, you got to fix it. And part of the way you avoid having an error in the first place like that is by testing your code as you go along. So this is very good. So we take in our time and we wait for it, and then we print out our inputs. Great. So now, so far so good. Now we need to figure out what the time's going to be afterwards, right? What our final time is going to be. So, right, we wanted to wait, we have 9 hours on the clock, right? It's 9 o'clock. We want to wait 2 hours, so we should get 11, right? So, obviously, we should add those things. So let's save it and run it. What is the current time in hours? It's 9 o'clock. I want to wait 2 hours. And so the final time is going to be 92 o'clock. What just happened there? Well, this is an example of a bug. It's not what you expected. You expected 11. And it's giving you 92. All right. And if you're following along in the textbook, choose your answer. And now, as you can see, the answer is C. Python is doing string concatenation, not integer addition. So this issue it's fairly easy to spot because what we were doing was we were printing out step by step what was going on. Printing is very useful for debugging purposes, right? What was going on here? Well, remember from when I was talking about the input statement, input always takes in strings, and string plus string is equal to string. So how do you add strings together? You glue them together, and that's exactly what happened with 9 and 2 over here. It's not 92 o'clock, it's 9-2. So, how do we fix that? We go and say, okay, let's go ahead and fix that error rather than trying to move on and figure out other stuff. So, let's go ahead and now put in, it is 9 o'clock, and I want to wait 2 hours, and so now I get 11, right? And notice that the print statements for this have been removed since I'm pretty sure they're working. No need to gum up the code like that. So here I've added them to I've simply casted them into ints and added them together and printed the last thing. However, if I now add, say it is midnight and I'd like my alarm to go, and let's say it's 11 o'clock in the evening, okay, not midnight, and I want my alarm to go off at 7 in the morning because I'm a masochist or something. So 8 hours later, it says that your alarm should go off at 31 o'clock, which does not work. So we need to wrap around. And as we've seen from our exercises, the appropriate thing to do here is to use modular arithmetic. But it's important to test. Here's another thing that happens. You need to test your code on not just one value, but a lot of different values. It's very hard to think of what can go wrong, but it's part of the skill is learning to anticipate how things can go wrong. So debugging is a very, very interesting process. But most importantly, it is a normal process.